Hello everybody, and welcome back. While we're doing hyperbolic compass and straight edge constructions, we've been making a whole bunch of new tools to replace the old ones that I lost, just got rid of because I didn't want to keep getting confused with the Euclidean tools. But I thought I'd do something a little different. I'm not going to construct a tool, I'm actually just going to construct a polygon, specifically an equilateral triangle, because that's a very nice basic construction, still works the same way you'd expect. Want our point set back to blue. So what I'm going to do is I'm going to create a length here. Might even name these guys A and B. And with this length, I'm going to create an equilateral triangle. Now, equilateral is the key because we're definitely going to know that the lengths are the same. Now, if I recall correctly, and it's been a while since I had to do hyperbolic geometry, the angles themselves are also going to be equal. They're not going to be 60 degrees, because I think I've mentioned in the past one of the things about hyperbolic geometry is that the interior angles in a triangle always sum up to less than 180 degrees. And the difference is actually what's called the defect, which is some interesting stuff, and you can learn more about triangles and things like that in hyperbolic geometry. But if I recall correctly, if you have a length and an angle subtending that length anywhere in hyperbolic geometry, it's always the same angle. Angles and lengths are connected in this way, and that's sort of, if I'm remembering, and I might just be completely making things up off the top of my head, but if I'm remembering correctly, and again, no guarantee of that, but if I'm remembering correctly, because angles determine lengths and lengths determine angles, they're sort of locked together, that's sort of an explanation as to why you can never have similar triangles. If you have similar triangles, you must have congruent triangles. Anyways, let's create our equilateral triangle, and it's the exact same way that we did it in Euclidean space, and that's basically been my catchphrase this whole time. So we know it's going to be the same lengths here, because we've got circles, and circles represent the same Euclidean length, or not Euclidean, hyperbolic lengths. So we pick another point, doesn't really matter which, and that's the other point on our triangle. Now we can clean this up so we can bask in the glory of our new equilateral triangle. Now these lengths are the same, but this sure as heck doesn't look like any equilateral triangle. And this is one of the things I like about hyperbolic geometry, is that it's a crazy different perspective. Okay? As we bring A and B out further and further, we do still get an equilateral triangle. We can sort of try and space it all evenly and maybe make like a peace symbol or something like that. But or this is a car symbol, isn't it? This is a Mercedes, I think. I don't know. But we can see the angles are actually. This is a triangle who almost has a zero angle, 0 degrees everywhere. And as we get closer and closer to the outside, that is what happens. And yet it's still all the same length, all the same side length. And if I'm recalling correctly, again, you can look this stuff up for yourself. Hopefully with this series I've at least piqued your interest a little bit in hyperbolic geometry, even if maybe I haven't piqued your interest in constructing things with GeoGebra, because sometimes it fails. But you can certainly look up and see if I am correct. I do believe it is equiangular if it's equilateral. And that's a nice connection there. But we do know that these lengths are all the same because of the way we constructed them with circles. And as we move them towards the center, it starts to look more and more like an equilateral triangle. It's not going to be 60 degrees, 60 degrees, 60 degree, but it's going to get really, really close to 60 degrees. In fact, you can construct an equilateral triangle, and you can make it so that you have specific angle degrees. You can go between 0 and 60. You can't actually get to 0, and you can't actually get to 60, but you can have any range in there. And I think that's kind of nifty. So, thanks for watching, and I'll see you guys in the next video.